Good morning, everyone. My name is Andre Siron, and my topic today is on the preparation of levoglucosanone from cellulose using sulfuric acid in polyethylene glycol. So first is the scale and optimization. Majority of the materials listed throughout this experiment are relatively cheap and readily available. But however, due to the extreme safety precautions the authors emphasize, a moderately sized scale can be used in order to run this experiment safely. And listed below are just some of the materials and the costs. Next is the checking process. To summarize, what the authors noted are that potential hazards are associated with polyethylene glycol, sulfuric acid, methanol, cellulose powder, etc. The use of PEG 4000 gave lower yields of product, and a range of cyclic chlorine ethers were observed by GCMS. 95 to 98% sulfuric acid and methanol were purchased from Sigma Aldrich and was used as received. Finally, standard grade Wattman ashless cellulose powder and microcrystalline cellulose was used. Next is the reaction apparatus. So how it works is the resulting powdered mixture is transferred using a large powder funnel into a 1 liter 3-necked round bottom flask. From there, the left neck is equipped with a distillation head with the water-cooled Liebig condenser and 100 milliliter receiver flask. The center neck is equipped with a 29 by 32 cap, and the right neck is equipped with a thermocouple inserted through a 15/25 rubber septum. From there, the two traps are connected to a distillation setup, with the first one being a 100 milliliter 2-neck flask, and the second trap is a cold finger. So here are just some of the reagents and starting material. We have levoglucosanone or LGO, sulfuric acid, polyethylene glycol, and cellulose. And on the right is just the chemical structures of how each reagent or material looks. Next is the procedure. So first is to ground to a coarse powder 200 grams of polyethylene glycol in a mortar and pestle and place in a 500 milliliter beaker. Next, you want to add a diluted solution of 2.5 grams of sulfuric acid in 15 milliliters of methanol in an ambient temperature. Next, you want to use a 18 centimeter large spatula to distribute the acid into the powdered PEG and allow most of the methanol to evaporate. From there, 50 grams of cellulose powder is added, and the powders are combined by stirring with the spatula for 3 minutes, giving an intimate mixture of PEG/acid and cellulose powders. Next, the powder mixture is transferred using a large powder funnel into a 1 liter 3-necked round bottom flask. Next, you want to connect the two traps to the distillation apparatus and finally cool to negative 78 degrees Celsius using a dry ice or a methanol bath. So here are just some of the images. So figure 1 shows the ground PEG 4000 or the polyethylene glycol. Figure 2 shows on the left side the sulfuric acid being added to the PEG and how the mixture should look like with the PEG/acid cellulose mixture on the right. And next is the reaction apparatus and the labeled parts within them. Next is the reaction workup. So this setup is evacuated using a rotary vane oil pump to less than 1 milliliter of mercury, and the mixture is heated over 15 minutes to 170 degrees Celsius by a mantle heater. So during this time, the solid PEG/cellulose mixture is melted and the colorless solution begins to char and turn black. When the solution reaches 170 degrees Celsius, the pressure is at 3 milliliters of mercury, and formation of a pale yellow distillate is observed, and the distillate begins to collect in the receiver flask. And then a heat gun is used to warm the distillation head to assist the distillation of the LGO and to avoid reflux of the mixture. Heating is then continued at the temperature is kept between 180 and 190 degrees Celsius for 30 minutes, at which point no more product distills. And upon the completion of the distillation, a pale yellow liquid, roughly 29.8 to 31 grams, is obtained, which mainly contains the LGO, furfall, and water. After that, the entire process is repeated from the two independent reactions are combined, and in total, 100 grams of cellulose was pyrolyzed. And then 60 milliliters of ethyl acetate is added to the distillate at an ambient temperature, specifically 22 degrees Celsius, followed by solid NaHCO and a 3.1 centimeter Teflon coated magnet oval stir bar. The reaction is allowed to stir for 15 minutes to facilitate the evolution of CO2 gas, and the mixture is transferred into a 100 milliliter separating funnel, and the flask is washed with ethyl acetate, which is added to the separatory funnel. And so here are just some of the resulting images. On the left side, you will see the PG cellulose mixture, as I said previously, that it turns char black. And on the right is the resulting distillate that formed yellow. Next is purification. So the residue is purified by flash chromatography on silica gel using a 10-to-1 ratio of hexane and ethyl acetate. Purification is also possible through distillation, as the product received from chromatographic purification is concentrated on the rotary evaporator and afforded LGO as a yellow oil. Purification of the residue by distillation under vacuum is also possible. However, complete separation of lower boiling furfall and from the LGO requires a long fractioning column, and decomposition of the LGO can occur if the acid remains in the mixture. Next is proof of purity. For the amount of product produced on this scale, flash chromatography was found to be the most reliable. Purification of residue by distillation under vacuum is also possible. However, complete separation of lower boiling furfall from the LGO requires a long fractioning column, and decomposition of the LGO can occur if the acid remains in the mixture. Vacuum distillation, specifically half a milliliter of mercury of the furfall slash LGO mixture before chromatography from a 25 milliliter tear-shaped flask, is fitted with an 11 centimeter column, eventually led to give two fractions. The fraction boiling at 63 to 81 degrees Celsius contained LGO of 1.47 grams, 1.5%, and 80% purity, contaminated with furfall, and the fraction boiling at 81 to 86 degrees Celsius contained LGO as a pale yellow with 6.83 grams, 8.9%, and 97% purity. Um, Side note is that purity assessment was performed using a QNMR using dimethyl fumarate as an internal standard. Next is the safety note and warning hazards. Prior to performing each reaction, a thorough hazard analysis and risk assessment should be carried out with regard to each chemical substance. An experimental operation on the scale plan and in context of the library where the procedures will be carried out. Since the pyrolysis reaction happens at a high temperature, it is critical to ensure that the operation is within a thermosafe zone, and it is intended for the uses by persons with proper training in experimental organic chemistry. They also mentioned that all hazardous materials should be handled using the standard procedures for working with chemicals described in the references, such as they mention here the prudent practices in the laboratory. Next is the discussion. So to summarize, levoglucosanone or LGO is a small chiral molecule formed when cellulose or levoglucosan is heated in the presence of acid. It is being developed as a biorenewable platform chemical that can be produced without costly fermentation following acid pretreatment of lignocellulosic biomass. Although this procedure described here is readily available, cellulose powder in place of biomass. And with the right materials and equipment, I do believe that this reaction can be done under the lab with the proper safety precautions within a smaller scale. And below is just the overall reaction. Next are just some of the authors and the universities they attended. And this is my works cited sources. Thank you.